Welcome back everyone to part 2 of our supervised learning project solutions. In part 2, we're now focusing on cohort and churn analysis, essentially trying to segment customers based off their tenure, creating those cohorts and seeing how their behaviors on churn differentiate between the cohorts. Let's head back to the notebook and continue where we left off last time. Okay, here I am in part 3, churn analysis. And so the first thing we want to figure out are what are the 3 contract types available? And we can just confirm this. We've already actually shown this in a couple of other visualizations. But if you check out the contract column, you can call unique on it. So call unique as a method. And it'll tell you there's 3 main contract types. There's the month-to-month, a 1-year contract, and a 2-year contract. And then we can also display tenure, unique. And you notice tenure is essentially someone who had a tenure of 1 month, 2 months, 34 months, 12 months, etc. So lots of different tenures as well. So let me go ahead and comment this out. The next thing is we want to create a histogram displaying the distribution of that tenure column. So how many people are in 1 month, 2 months, 3 months, and so on. And when we're thinking about a histogram, we're just going to use SNS histplot for this. So let's go ahead and show that here. All we need to say is sns.histplot, say the data is DF, and then the column we're interested in is the tenure column. If you just run it with no other parameters, you'll get probably too little amount of bins here, so we can expand on this, especially considering that we have 7,000 or more rows. We can say bins is equal to something larger, maybe like 60 bins. Obviously, this is something you can experiment with, but this is just to get an idea of the distribution of the count. And what's interesting here is you have a very high number of people that are with a very low tenure, almost like 1 or 2 months. And if you want, you could also use something like a bar plot to actually show a bar distinctly for every single tenure type instead of a distribution here, kind of up to you. But the main idea you should be realizing here is you have a large amount of customers that are only hanging on for maybe 1 or 2 months. Now, is that a problem? Kind of depends on what the customers are actually asking for. You'll probably see that a lot of those customers are just month-to-month contract customers, and maybe they really only needed the service for 1 month, so it's not a big deal that they churned because there was no way you were going to convince that customer to stay on longer because maybe they only needed the service for 1 month and had no intention, regardless of whatever coupon or promotion you gave them, that they would stay on longer than that. What's also interesting is that the second highest count is beyond 70, so 72. So these are your long-term customers, the people that are pretty much locked into your service and just need it. And then we have everyone else in the middle. And you'll notice that there are these spikes kind of occurring at intervals, and those are very likely occurring along some sort of yearly contract basis. So there's probably a spike around 24 and 48, etc. Okay, so what we're going to do now is we're going to move on to discussing that idea of this distribution per churn and per contract type. So what we can do is we can use the Seaborn documentation as a guide, essentially telling you to check out what you can add in for things like this plot where you can specify a column and a row. So what we really want to do is repeat this plot here, where I'm showing you the count or distribution, and then we've also separated this out into churn. So the top row are people that did not churn, and then the bottom row are people that did churn. And then we also have it on a contract basis. First column is month to month, second column is 1 year, and then the third column are the 2-year contracts. You'll notice that there's essentially almost nobody churning. So here we have churn yes, and notice how flat it is. So almost nobody churning on the 1-year and 2-year contracts versus people over here on the no churn. There's a lot more people not churning when they're on 1 year and 2 year. So all this is to say that you're very likely to churn if you're on a month-to-month contract versus a 1 year and 2 year. And so that's what this is displaying here. So notice that it's very flat, almost no instances of churn on a 1 year and 2 year contract versus the month-to-month. What's also kind of interesting here is it's fairly evenly split when you're on month-to-month, whether or not you're going to churn. So there is still focus there. How do we actually make this plot though? It's quite simple. We say sns.displot, so D-I-S-P-L-O-T, and you're going to say data is equal to DF, same as before, X is equal to tenure, and then say bins is equal to 70. And if you just run this, it's going to look a lot like the plot we just had before. So let me scroll up here. So this looks really similar, except what I'm also going to do here is add in the following. I'm going to say define the columns based on the contract column, and define the rows based off the churn column. And that gives you this separation that, whoops, make sure we spell this correctly. This should say capital C contract. There we go. Let's run that again. And now I'm going to scroll up here, and there we have it, that same plot. Again, this allows you to compare directly both on terms of churn and on terms of contract type. So what interpretations can we make here? Essentially, not to worry too much about 1 year or 2 year contracts because they are very unlikely to churn in comparison to month to month. And what's interesting about month to month is that there's essentially kind of evenly split churn. So that's really where your focus should be as a company. How do we actually get people on a month to month to stay longer and not churn? And maybe there's not going to be much you can do for the person that only needs your service for 1 month, but what about the people that need services for 10 months or 20 months or 30 months? 30 months is a really long tenure, and it's kind of interesting that they're still on month-to-month tenures here versus just going straight for a 1 year or 2 year contract. If someone's on tenure for 48 months, why didn't they just sign up for a 2 year contract? We also saw previously behavior that people tend to churn based off their total charges and monthly charges. So maybe they're getting charged more on a month-to-month, even though they intend to keep it for a longer tenure. So what we could think about are promotions that basically say, hey, I noticed you're on this plan for more than 12 months. How about you sign for a 1 year contract, and that way you can lower your overall bill, but we keep the customer for longer in their lifetime span. Let's go ahead and move on here. So we want to display a scatter plot of total charges versus monthly charges, and we're going to color this, or that is color by hue, for churn itself. So how do we do this? It's actually pretty simple. We're simply going to say sns.scatterplot. Going to say data is equal to df, and then say x is equal to monthly charges column, and then say y is equal to total charges. There we go. And I'm also going to add in, if we just do this basic of monthly charges, and whoops, make sure we have this correct. This should be x is equal to monthly charges. There we go. So if we just do this by itself, monthly charges and total charges there, it makes sense that you get essentially this linear relationship here, because obviously as you gain more in monthly charges, you're going to gain more in total charges. But what would be interesting to see is how this relates to churn. Are people that are getting charged a lot per month churning, or people that are getting charged a lot or charged not that much per month churning? So how does this actually affect the behavior? What we can do is add in a hue here based on churn to see those results. And this starts to get a little hard to actually read. So this is where we start editing the figure a little bit. And even then, it might still be a little hard. So we'll say fig size is equal to, just make this figure larger, like 10 by 4. And then say DPI is equal to something like 200. And if you run this, you start to get a nicer plot. And what's still a little kind of annoying here is we get points on top of each other. So I could add an alpha parameter to add in some more transparency here. Maybe make alpha like 0.4. And when you add in that parameter, then you don't really need the line width along the actual dots to be that thick. So what we can do here, say line width equal to something a lot thinner, like 0.3 or something like that. And so this essentially just appears as dots. So we can see that a lot of people tend to churn when their monthly charges are higher. And again, that makes sense, because if you're having to pay more and more per month, you're probably going to try to figure out a better service or something that's cheaper for you. So you're going to end up churning. But what's interesting here is you have these people paying a lot per month, but the total charges are very low. Versus these same people up here, they are paying the exact same in monthly charges, but you're able to extract more out of them in total charges. Because really, from the company's perspective, what they want to maximize are the total charges. You don't really care too much, depending on the lifetime of the customer, what the monthly charges are, as long as you can extract an increase in total charges from those customers. Essentially saying, you rather have one customer paying $10 a month for a full year versus one customer just paying a one-time payment of $100 a month, but then immediately quits after 1 month. Because in the first case, you get $120 total, and in the second case, you only get $100 total. Now, something to keep in mind is what's the actual cost of delivering that service, where you could end up losing money delivering the service for 12 months versus just 1 month. So that's another thing to keep in mind here. There's not really any cost associated for this particular data set, and obviously that starts to get more entangled with your business alignments, your marginal cost, etc. But it's something you should be thinking of here. What is causing these people to churn? And from all the plots we've seen so far, if you're getting charged a lot per month, you're very likely to churn, especially if you're on a month-to-month contract and you're only needing the service for a few months. So maybe just get fed up with the service, you're paying too much, you're on a month-to-month, so you just quit and churn. Okay, so what we're going to do now is focus on cohort analysis. Oh, something to point out here is I set a different palette for this image that we have, and the palette I used is called dark2. So what you can do here is say palette is equal to, and then the string code dark2, run that, and you'll get the same palette. And obviously you can keep changing things like alpha, line width, marker size, etc. But the main thing to note here is you're getting a lot of churn for people that have high monthly rates, and you're not getting as much total charge from these people. Very likely they're on a month-to-month contract, and as we saw up here, those month-to-month contracts could end their tenure early. So we'll come back down here, and I want to create cohorts based on the tenure. And what we're going to do first is create and treat each unique tenure length. So whether you're on 1 month, 2 month, etc., we're going to treat those as its own cohort. Later on, we'll do something more realistic, kind of segmenting them into larger groups. But for right now, each single tenure length is its unique cohort. And our main goal here, if we scroll down, is to create a plot that looks like this. Essentially, what is the percentage of churn per that tenure? So for a tenure of around 1, you're getting almost 60% churn, and eventually it starts going down, down, down. As people stay on the service longer, less people are likely to churn, which kind of makes sense. And what we have to do is create a series that looks like this. Essentially, tenure of 1 month, what's the churn rate? Tenure of 2 months, what's the churn rate? Lots and lots of different ways you can do this. I found the easiest way was to separate this out into people that did not churn and people that did churn, and then just calculate the percentage that way. So let me show you my logic, and then you can also check out many different ways of doing this. But let's just calculate the people that did churn based off their tenure group. So yes, churn, I'm going to define this as df group by, and we're going to group by churn, and then group by tenure. In fact, let's just show you how this is constructed first off. So if I say group by churn and group by tenure, I run this, it's waiting for me to call something on it. I'm just calculating percentages, so I care about the count here. So notice here, now I see people that did not churn and people that did churn, as well as their tenure and the count of how many rows. So really what I want to know here is if I transpose this, so it's a little easier to read, then I'll have churn as my columns where I have no versus yes, and I can just grab one of these, such as grab everything from yes. And notice here, this is telling me the exact counts. And it makes sense that the counts are the same for each of these features because it's just telling you how many rows there are. So there's 380 people that did churn for tenure 1. There's 123 people that had a yes churn for a tenure of 2, and so on. So again, we're using this group by, I'm counting them up, and then transposing it so I can quickly just grab yes. Lots of different ways you can construct something very similar here, but this is the way that made the most sense to me. And it was most adaptable. So here I have yes churn. I'm going to do the exact same thing, except I'll do it for people that did not churn. We'll say no churn, and then I have no here. And if you take a look at no churn, something that's critical to note is its overall structure is the exact same. You have customer ID, gender, senior citizen, etc. And then you have the row counts for people that did not churn. So again, if I replace this with yes churn, the only thing that you really see change here are the numbers themselves. Now keep in mind, I actually want to calculate the percentage of people that churned. And that's going to be the amount of people that churned divided by the sum of yes and no, the total amount of people. So the amount of people per tenure is equal to the people that did churn plus the people that did not churn. That's the total population for this particular tenure. And then if I want the actual churn rate, I would say yes churn divided by the sum of these two, the total pop or population. So let's figure that out. How can we do that? Luckily, these are essentially just data frames that I can very quickly add together. So I can say churn rate is equal to 100 times yes churn divided by the sum of no churn plus yes churn. So what does that actually look like? Let me just show you here before we get churn rate. So that's going to give me the values here, the percentages. Now it makes sense that the percentages are the same for every single feature. In the same way, it makes sense that the count of the rows is the same for each feature. But what I'm showing here is the tenure for 1 month. You have 61.99% of people churning. So again, that's yes churn divided by the total sum of people. And what probably makes this a little easier to read is if you just start grabbing a single feature here. So what I can do now, say, is churn rate is equal to this data frame. And because I have so many repeating values, what I can do is go ahead and transpose this. And keep in mind, you don't technically need to transpose these things. You can grab them by rows instead of columns. It's kind of up to you, however you prefer to think about it. But for me, it was simpler to just say, okay, now that I have the tenure on the index, I can grab any of these columns. So I can just grab customer ID. And now I have the churn rate, which was exactly what I was looking for. And so I have this nice feature, so I can plot this out. Lots of different ways you can plot this. Something you can do here is just say .plot, run that, and it should give you the same plot as we saw here. And then you can edit the figure and so on. Okay, so that takes us then to the next task, which was essentially creating that plot, which is how I did that. I just created a line plot. Or you can use SNS line plot and then grab the index and plot the values against it. But hopefully just take your time to understand these 3 lines of code that I did here. I grouped by churn, then by tenure, counted the number of instances of people that did churn for that tenure, and then I only grabbed the people that did churn, and then I did the same thing here, but only grabbed the people that did not churn. And then I can easily calculate the percentage and get something that looks like this, which then I can easily plot. All right, kind of complicated as far as the thinking, but the actual code is relatively simple. Now we're going to move on. We just showed you how to make this plot, so we'll go ahead and skip that. And now we want to create these broader cohort groups. So realistically, you're not going to take every unique value and treat that as a cohort. Instead, you want to segment customers into things that are reasonable based off your business. So based off this business, it's probably reasonable to group them on 1 year, 2nd year, and then maybe the next 2 years after that, and everything else. So let's go ahead and do that. You can also make your own cohorts. Easiest way to do this is just create a function you can apply. So I'm going to say there's a cohort here. It takes in the value of tenure. Recall tenure is the actual value. So let me show you real quick. It's going to be tenure. And then we can also show them something like, whoops, we're just grabbing a single column here. So recall tenure is just a number, whether it's say 1 month, 34 months, 2 months, etc. So I'm going to end up applying the cohort function to this column. So what do I actually want to say here? I'm going to say if tenure is less than 13 months or 12 months. So kind of up to you how you want to define this. But I'm going to say if tenure is less than 13, go ahead and say return 0 to 12 months. And then we're going to continue doing this for the rest of the cohorts. So we'll say after that, elif tenure is less than 25 months. Then I'm going to return 12 to 24 months. Whoops, 24, not 14. 24 months. So that's my next cohort. We'll make 1 more or 2 more. Tenure less than, let's say, 49 months. That's going to return people that are between 24 months and 48 months. And then the last one, keep in mind it's technically 25 to 48, but you get the idea of what we're trying to say here. And then we'll say else return over 48 months. So now what I'm doing is I'm grouping people together on these 4 categories. The people that stayed for 1 year, people, and note here, they stayed more than 1 year. They stayed somewhere between 1 year and 2 years. And then these people stayed somewhere between 2 years and 4 years. And these are the people that are staying on your service more than 4 years. So based off these cohorts, you can do a lot of interesting analysis. So we'll run this. And then if I say df tenure, apply cohort, whoops, make sure we spell this right, cohort function. Now I get the 0, 12 months, 12, 48 months, etc. So off of this, I can say df and make a new column called, let's say, tenure cohort. I'm going to set this equal to tenure apply cohort, run this, and then say df tenure cohorts. And let's also add in the tenure. Run that, and so we're getting something that looks good. Tenure cohort and the tenure looks like everything's matching up as expected. Let's now plot this out, essentially creating the same plot as before, but I'm now going to color it by the tenure cohort. So we actually did this plot already. I'm going to scroll up here and then just copy the plot here. So let's copy this. I'm going to come back down and then paste it here. So it's the exact same code. The only thing I'm changing now is instead of coloring by hue, I'm going to color it by my tenure cohort. Run that, and now you can see the interesting behavior where you can see that you're starting off relatively equal as far as the cohorts, but the people that are only staying 0 to 12 months, you're not getting as much total charges from them versus the people that are staying over 48 months. Now, does this make sense? Yes, intuitively, you can probably see that the longer the person's going to stay on the service, especially if they're staying over 48 months, the more total charges. What's interesting to note here are kind of the drop-off rates. So relatively, this is kind of expected equal behavior, but what could be kind of interesting is if you suddenly saw one of these colors drop off immediately. And that would indicate maybe check the monthly charges and explore that further. What we can also do is create things like count plots based off these cohorts. So I can create a count plot showing the churn count per cohort, and that's the next task here. So create a count plot showing the churn count per cohort. How do we do that? It's actually quite simple. We say SNS count plot, data is equal to df, x is equal to tenure cohort, and then we can say hue is now equal to churn. Run that, and you'll get this plot. Again, showing you that people that are staying on the service for over 48 months are not likely to churn. Versus if you're only on the service for 0 to 12 months, you're very likely to churn. In fact, it's kind of like half and half. Half people churn, half people don't churn. And we can explore this further based off the contract type, which is what the next plot or next tasks asks us to do. Essentially create a grid of count plots showing counts per tenure cohort. So how do we actually do this? Well, in this case, we can't use count plot directly. If you check the documentation, you have to actually use cat plot. So we're going to say sns.catplot. Say data is equal to df. Say x is equal to tenure cohort, because that's what I want on the x-axis. And say hue is equal to churn. And because I want a count plot, I have to say kind is equal to count. And that's why I'm saying cat plot here, because if you just run this, it's kind of the same plot we just saw. But using cat plot allows you for that facet grid application, where I can say column is then equal to contract, and the rows are now separated out. Actually, we just want to do it by contract for columns, but I could separate out the rows by something else if I wanted to. So I can now see here contract month to month, 1 year, 2 years. So again, people that sign up for 1 year or 2 year contracts, regardless of how long they stay on the service, they're actually less likely to churn, which is kind of interesting. That again starts getting you the ideas of what's the relationship between monthly charges and total charges. Am I actually optimizing this? Then there you just have to start thinking about what's my cost to deliver the service per month, and we kind of want to optimize for lifetime value of the customer. Lots and lots of other interesting visualizations that you can try out here, and I would encourage you to do so. But hopefully it's kind of sparks a bunch of ideas for you to check out further within the data set. All right, that's it for this part. Coming up next is predictive modeling. I'll see you there.